Hello students, today's paper 22nd January morning shift JEE. So chemistry paper analysis will see how the questions are framing, right? Okay, so section A, question number 1, what the question was telling. So here it is, the question. Consider the given central metal ions of low spin complex. They said low spin complex and choose the correct increasing order of unpaired electrons. Correct increasing order of unpaired electrons. So we know one condition, right? This question has been framed from the coordination compound. So low spin complex. That means what happened? We have to force pairing required. Force pairing has to do in this case. Force pairing. Okay. Force pairing we need to do. Okay, so given ions, what are they given? Manganese 3 plus. Manganese 3 plus, its configuration will be having, so 4s0, 3d5 you will be having. So 3d5 means what happened? Let us draw the d orbital 1, 2, 3, 4. Right? So 5 electrons are there. So 1, 2, 3, 4, 5. Now, so try to force pair this one. So why they're telling that the question was in the low spin complexes. So force pair after doing the force pair, what happened? So here two electrons, here two, here two. So here number of unpaired electrons one is coming in the case of manganese 3 plus. Same for the case of chromium 3 plus. Chromium 3 plus, what will have? In this case code electronic configuration. So AR 4s 0 3D. So Cr3 plus, right? Cr3 plus means what happened? 4s 0 3D3 will be the configuration you will be having. Now in this case, if you do force pairing, no pairing will take place in this condition. No force pairing will take place. This one. So here n is equal to 3. Number of unpaired electrons in this case will be 3. Now, if you see the Fe3 plus, in this case, electronic configuration of this one, so 4s0, 3d5, 4s0, 3d5 you will be having. So actually iron atomic number is 26. Iron atomic number is 26. So what happened now? So 1 second guys. So it has to be 3d4. It has to come 3d4. Why? Manganese atomic number is 25. 4s2 3d5. So from 25 electrons, remove 3 electrons. That means what happened? So 4s2 2 electrons, then 1. So 3d4 will come. That means what happened? If you do force pairing here, so you will be getting like this, right? So let us do something here. Yes, we'll be having like this. Only one electron will be. So here n is equal to is not 1, but n is equal to 2. So here n is equal to 3. In the case of iron, atomic number is 26. 26, it losing 2 electrons, 23 electrons are there, right? From the 26, 3 electrons gone, no? So 23. Now, so it will be like this. 4s2, 3d6. 3 electrons, 2 from this one from this one. So 3d5 you have. So when you have 3d5 configuration, after force pairing, 1, 2, 3, 4, 5. So now do the force pairing. So what will get here? 1, 2, 3, 4. So 1, 2, 2, and this one. So here n is equal to 1 will be the number of unpaired electron. Now let us see the last one, cobalt 3 plus. Cobalt electronic configuration in the ground state, what we have? Ar 4s2 3d7 you have, atomic number is 27. Okay, now 3 electrons removed. That means what happened? 2 from the S, 1 from D. So that means what happened? AR. So 4 as 0, 3D6 you have. So here you will be having the 0 number of unpaired electrons are there. So pairing. So you'll be having the n is equal to 0. That means what happened? Cobalt has to come. Cobalt has to come minimum. Cobalt has to come minimum. That means what happened? So this C option, D option will not come the answers. Your answer will be either one or two. In the which is maximum here, chromium is maximum. Chromium will be maximum. Both cases, chromium is maximum. Now Mn3 plus Fe3 plus. Where is more number of electrons? Mn3 plus is 2 electrons, Fe3 plus 1 electron. That means so first option will be the correct answer for this question. Now question number two, what they telling that? So they given the reagent, we have to match their formulas, right? So first one, so here it is. Failing solution, Clemmensen reduction, Tollens reagent, Wolff-Kishner. So let us see. Clemmensen, Hg, zinc amalgam, and HCl. Whereas Wolff-Kishner, so what we have? N2H4, KOH, N2H4 in ethylene glycol in basic medium. So that will be having. So let us see what we happen in this case. So 4 must be C. 4 must be C. That means this will not come. This will not come. 4 must be C. And Clemenson B2. B2 C4. B2 C4. So B2 C4 both you have having. Now failing solution what happened? Failing as well as tolerance. Tolerance reagent is what happened? It will be ammonical silver nitrate. That means what happened? A must be 3. A must be 3. Whereas failing solution is copper sulfate in basic medium. This. So you will be having A3D1. That is option C is the correct answer for the given question. Question number 3, what they have given, it is from the thermodynamics concept. Okay. Thermodynamic concept, here it is. So for the reaction given below at 25 degrees Celsius temperature, okay, the given the equation, that is equilibrium reaction they given, okay. The question asking is what is the ln Kp value they are asking. Ln Kp value they are asking. Okay, so ln Kp value what will happen? Let us look at here. We have this relation, right? Del G naught is equal to minus RT ln K. Kp you can take here. This one formula we have to use in this condition, but del G naught is not given directly. We have to find out the del G naught from the equation. So here del G naught is equal to del G of, can keep here, del G naught of product minus del G naught of reactant. So now product how much they given, that is 2 times of A. So 2 into minus 50.384 minus of minus plus, that is only one time of A, that is 100. So after solving this, how much we are getting here? Let us calculate. So 50.384 into 2. Okay. So this you are getting minus 100.768 plus 100. So that means what to do now here? Subtract the 100. So you're getting the 0.768 will be the del Z naught. Okay. So after getting this one, substitute here directly, right? So this value we're getting is minus, guys, right? Minus 0.768 is equal to minus R value. R value how much? Take 8.314, right? So, but this value you got it in kilojoule per mole. Now, this R value also take it in kilojoules. So, R is equal to how much? R is equal to 8.314 joule per mole per Kelvin, right? So, now 8.314 by 1000 if I take, it becomes kilojoules. Temperature is 298 and ln Kp value you'll be getting, right? So after solving, how much will get it here? 8.314 into 298. So 768 by, so 0.33. So minus minus cancel out. You're getting ln kb is equal to, so 0.309 is coming. The correct answer for this question is option C is the correct answer for this question. Now, now what happened? Fourth question. Statement 1. Sucrose is dextrorotatory. Up and upon hydrolysis, it becomes levorotatory. So this statement is perfectly perfect. So this question is as framed from the NCRT. NCRT page number, NCRT, NCRT page number, old book 417. You can get the answer for this question. So statement 1 is absolutely correct. Why? Sucrose upon hydrolysis, it will give you the levorotatory. How it will give? Let us see here. You have been like this. So sucrose on hydrolysis, it will give the, so alpha D glucose and fructose will come. It will come. So fructose and glucose will be framing, right? So here it is fructose plus glucose you are getting. Now, here alpha is equal to, you are getting, so plus, so fructose you will be getting alpha is equal to minus 92.4 degrees. Here glucose is equal to plus 52.5 degrees is coming. So if you see here, orally, alpha value of fructose is more laboratory than glucose. But in the second statement, what they given, sucrose on hydrolysis give the glucose as well as fructose, such that laboratory of glucose is more than dextrose. This is a false statement. Laboratory of fructose is more than glucose. Statement 2 is false. Statement 1 is right. So why 1 is right? Orally we're getting negative alpha is coming. That means this is also called as a invert sugar, we can call this one. This is also called as a invert sugar. That means statement 1 is correct, 2 is wrong. So that means option C is the right answer. Which of the following is the correct order of the reactivity of the given nucleophiles when treated with a CH3Br in methanol? CH3Br in methanol. So here this will be having, so here methanol CH3OH. First of all, we should know methanol is what kind of solvent it is. Methanol is a polar protic solvent. Methanol is a polar protic solvent. Polar protic solvent it is. So polar protic solvent. So generally what happen here? Down the group nucleophilicity increases. Down the group in a periodic table, down the group, because solvation takes place. F minus a small solvation takes place. So less nucleophile that one. So down the group, nucleophilicity increases. That means what happen? I minus is more nucleophile than F minus. Now, if you see the C2H5 O negative, PHO negative. So here, first one, iodine means iodide will be the most nucleophile. So you can eliminate the option D easily. Option D easily we can eliminate. Now, least most nucleophile is iodide will come, that is I minus most nucleophile, because of the down the group solvation will be less, so it can able to attack very easily. Then what will happen after that? Here you can see this ethoxide, right? Oxide. So this will be again C2H5O negative. Then after oxygen again here. Then PHO negative. Then will be least will be having the this. Can also keep one more point. Left to right. Left to right. Nucleophilicity decreases. decreases. Here the reason is what we have reason here is based on the electronegativity size. But if you see the down the group, we have to see the size. Solvation we have to see. So least is Florido, most is Ido. That is option A is the right answer. Next one what we have. So this is most important question. Reactivity of the following basis of SN1 reaction mechanism. SN1 mechanism, it is favorable. So stable carbocation is proportional to the rate of SN1 reaction. This is the funda for this question. Okay. Now if you see here, if I remove this particular halide, no, we'll get the triphenyl cation will come. Here we'll get the 9 alpha H conjugation will come in this case. Here three side resonance is there, right? That means obviously we're getting that resonance is more. So first 4 will come, then after 3 will come. So this is particularly clear. 4 is must be more rate of reaction. That means what will have 2 and 3 will not come. 2 and 3 will not come. You will be having the either first option or fourth option. Now 4 after 3 is there. Then next what we have here, the Brits head rule. So always keep it both. This has to be 1, not 2. It has to be 1. 1 second. Let me make it this one. This is statement 1. This is statement 2. Okay. This one. Okay. Now, so here what we have. This will be more strain will be there. This one, if you try to make assume that carbocation will not form in the case of Brits head rule, because Brits heads rule what is telling that Brits headed carbon should be always sp3 hydrogen carbon, should not be sp2 hydrogen carbon. Suppose assume that here carbocation is forming. Suppose here carbocation is forming. Then in that case what happen? This is more strain. Why? Only one carbon is there in the Brits. Here two carbons are there, so kind of less strain. So in this case what happened? One is more stable than two. One is more stable than two. That means what happened? Rate of reaction 4 is more than 3, then 1, then 2 is the right answer. So 4 3 1 2. That is option 1 is the right answer. Next what happened? Statement 1, HX bond length is higher in HCl than HF. That is perfectly perfect only, no? So bond length, this is right. Bond length is proportional to atomic size. More atomic size, more is the bond length. If you take fluorine as, as well as chlorine, so size of chlorine is more than fluorine. If size is more, bond length also more in that. So this is the correct statement. Next one, the lowest boiling point of hydride in group 15 elements having covalence is 4. Let us see. Group 15 hydrides, what will happen? NH3, PH3, and ASH3, SBH3, then BH3. You have these hydrides. So all of this having the boiling points will order. So here amine will be having the more boiling points due to hydrogen bonding. This is more boiling point. Least one will be, so down the group boiling point increases. Boiling point increases down the group. Boiling point increases down the group. Down the group. Right? So now, so here phosphine will be having the lowest boiling point. Lowest boiling point. Lowest boiling point, what they say that it has to have covalence is 4. No, it's not having the covalence 4. No. Here how many covalence is there? Only 3 is the covalence is there in this condition pH case. That means statement 2 is a wrong. So 1 is right, 2 is wrong. 1 is correct, 2 is incorrect. That is option C is the right answer. Next, what happened? A compound A with molecular formula C9H10 H11NO. Now we'll try to see the DU for this one. DU. So degree of unsaturation for this what happened? So du formula C plus 1 minus H plus X minus N by 2. So here 9 carbon atoms plus 1 minus 11 hydrogens. Halogens is not there. Next nitrogens 1 is there. That means plus 1. Right? So here 10 minus 6. That means 4 is there in this case. 12 by 2. 12 by 2 how much? 6 only. No. 10 minus 6 4. That means your du will be 4. That means you will be having the 4 du will be available in that case. Okay, so let us see what can be the, so 10 minus, mm, okay, 1 second guys. This has to be minus 1. So this has to be, so 10 minus, this is 5. So this become 5. So du is coming 5. Try to find out where du is 5. So all the cases you will be having the du will be 5. Right? Chalo. So based on the du, we cannot get the answer. Chalo, we'll see this one. Okay. A compound is treated with the Br2NaOH. This is what happened. Half-man bromide degradation. It will give you X. See, if it is giving those kind of reagent, that means what happened? It has to have amide structure only, no? It has to have amide structure only, no? It is to have amide structure. C double bond O. It has to be like this, right? It has to be like this, right? This kind of case only it can able to get the Hoffman bromide degradation. X will come. X on reaction with NaNO2 on dilute HCl gives compound Y. That means if you do the, what is this? Diazotization, you know, NaNO2 HCl 0 to 5 degrees Celsius. Not mentioned, but it will go reaction that. You will get the diazonium chloride will form no? Na2 positive, Cl minus. Okay. Then if you treat with this one, CuCl, you will be getting the cyanide will come. If you do cyanide hydrolysis, what happens? Z is coming. If you do hydrolysis, Z is coming. That means carboxylic acid is coming. So this will come carboxylic acid. How carboxylic come? When you do complete hydrolysis of cyanide, you will get the carboxylic acid. Break this one. H positive, OH negative. Again, OH negative. Three bonds are there, no? Three bonds, you break it. Here H positive. Again, OH negative. So you got the carboxylic acid will come. So this you got the Z, and this becomes what you got here. This is coming as X is coming. Where X is? 1 second. Hmm. Okay. X must be aniline. So this is X. Now before this compound, we have to find out. Okay. X must be aniline. Now it is Y is coming. Okay. This will be Y is coming. Y treating with hydrolysis coming Z. Compound A on hydrolysis give also compound Z. Suppose if I take this one, A also has to give the Z when if you do the hydrolysis. When if you do the hydrolysis, compound A also will give the Z. That means what happens? Z will be, so A must be the one which after one hydrolysis it has to come carboxylic acid. So let us check it the where it can give the hydrolysis upon one hydrolysis case. So if I do here, no, I cannot get the Z. If I do here, I can get the Z will come. But what will happen in this case? The number of carbons will be not matching here. You can see here 9 carbons will come. But here what happened? 6 plus 1, 7. 6 plus 2, 8 only coming. So this will not come. Now this will be the correct answer will come. See here, if you do hydrolysis, no, H positive, OH negative, carboxylic acid, number of carbon atoms are same. So option C must be the right answer. Which of the following statement is correct regarding the nature and the direct influence of NO2? NO2, guys, NO2 group is a strong minus M effect. Strong minus M effect. Strong minus M effect. So if it is strong minus M effect, so it deactivate the benzene ring. Deactivate the benzene ring. Benzene ring for electrophilic aromatic substitution. Next, what happened? So it activates, right? Or else it direct the electrophile at meta position only. At meta position, this one. So these are the case. Let us see. First statement, first option, it activating the group at orthopair. Wrong answer. It deactivating group orthopair. No, it's not deactivating. It's deactivating but not orthopair. It is meta directing. It's deactivating group meta. This is the right answer. It is an activating group. No, not deactivating. This is a deactivating. So right answer is, so C is the right answer. Now consider the following sequence of the reaction. Identify A, B, C respectively. Just now we solved no diazotization. So what will get here? Diazonium chloride will come. So let us see here. Let me take here complete equation. Aniline they have taken. So after doing diazotization, NaNO2 HCl 0 to 5 degrees Celsius. So getting diazonium chloride is forming. Diazonium chloride is forming. Now, after this, it is reducing agent you are adding. Reducing agent. We can add here also, if they given ethanol also same answer will come. C2H5OH, it will be coming, benzene will come. Benzene will come. Right? Here benzene will come. Now, benzene, if you treat with the Br2, electrophilic aromatic substitution, right, will give to get in the orthopara, sorry, only this one will come. Okay, bromobenzene will come. So, A is this one, B is this one, C is bromobenzene. A is the diazonium chloride. A is diazonium, only one option is there, that will be option B. Next one, what we have, this will be schemid reaction, right? So coal-based schemid reaction, coal-based reaction. Here, if you take NaOH base, what happen? Acidic hydrogen base. So acid-base reaction will take place. Salt will form here. O negative, Na positive. Now, next case, what will happen? CO2. CO2 case, what happen? We'll do like this. So we'll take this one here, this one here, this one here. Now, whenever if you do this case, here CO2 will be acting as a electrophile. So this negative converting into pi, pi converting into negative. So we'll be getting like this. Next resonating structure will come negative, double bond, double bond, double bond, O will come. Now next step is carbon. So C, double bond O, double bond O. Now shift this one here. Negative charge attacking on this positive carbon. So you will be getting like this. So double bond C double bond O negative, then double bond here, you got it, this one. Okay. Now, next what happened? Here it is, positive charge is coming, right? So here hydrogen, positive charge. Okay, you got like this. Next what happened? Remove the hydrogen, right? Now shift this bond here. So you will be getting like this. Here Na positive will come. Na positive will be coming here. So we'll be getting like this. O negative, right? O negative, here double bond, here double bond, here double bond. C double bond O, O negative, Na positive. Now if you do acidification, okay, this hydrogen will be shifting into here. Now, next case what happened? After doing acidification, you will be getting like this. Double, single, double. So C double bond O, OH, then OH, right? So this will be having orthosalicylic acid, orthosalicylic acid, orthosalicylic acid. This one, that is option A is the right answer. Aldehyde will come when you take Ramer-Tamer reaction. Now you have the question number 12. Question number 12, what we have? We will be having two statements. KH is a constant with change in concentration of a gas till the solution is dilute at a given temperature. So KH depends on temperature directly, guys. Temperature. So KH Henry's law constant with a change in concentration of a gas till the solution is dilute at a given temperature. Change in concentration of a, so this is correct only. Now, according to Henry's law, partial pressure of a gas in a vapor phase inversely proportional to the mole fraction. So Henry's law condition, what we have, pressure is proportional to the, means pressure is proportional to, so solubility or mole fraction. If I remove the, if I remove the proportionality, we will get the Henry's law constant into X will come. So pressure is proportional to mole fraction of a gas. Partial pressure of a gas inversely proportional. No, it is not inversely proportional, but is directly proportional. Statement 1 is right, 2 is incorrect. That is option C is the right answer. Now we have question from the chemical kinetics. A gives two products, three different solutions they have taken. First solution is 10 molar concentration, volume 100, 10 molar concentration, volume 200. Here 10 mole concentration, 10 mole volume, 10 molar concentration. So concentration is same is there. See, so here what happened? It is a first order reaction they told clearly. It is the first order reaction. That means what happened? Rate is equal to K into concentration of A raised to the power of 1. This is the relation we have. So the concentration increases, rate of reaction also increases. Concentration, concentration increases, rate increases. Concentration decreases, rate decreases. So concentration decreases when the volume of solution, volume of, see, extra water they added here. Third case. So R3 is very less rate of reaction. Whereas R1, R2 both are same. Why? Same volume, they are not adding extra. R1 is equal to R2 and R3 is lesser than R1 or R2. That means R2 will be like this. Why? Extra volume of water they added. Dilution taking place. Dilution takes place, concentration decreases. Concentration decreases, rate of reaction decreases. So R1 is equal to R2, then more than R3. This one you will be having option 3. Now Bohr's radius of hydrogen atom is 2.12 into 10 power of minus 10 meter. Energy of electron how much? So try to find the radius formula. Radius is equal to, so here 0.529 n square by z square. Z value will be here given will be 1 only for hydrogen atom. Okay, so that is 1 only. It is in angstrom. Let me convert into meter. 10 meter. Now, so radius they given no 2.12 into 10 power of minus 10, 0.529 n square into 10 power of minus 10. So minus 10 cancel out. N square is equal to, I think, 4 will come approximately here. So n is equal to 2 will come like this. Okay. Now use the formula energy. E is equal to minus 13.6 minus 13.6 Z square by N square. Electron volt per atom. Okay, minus 13.6 Z value, again atomic number is 1 square, N value is 4, 2 square is 4, into electron volt, we need into joules only, no? So 1 electron volt is equal to, so 1.69 into 10 power of minus 19 joule we can convert here. Multiply here 1.69 into 10 power of minus 19. So after solving this one, how much you're getting? So let us see how much will come. 1.69 into 13.6, so by 4, 5. 5 point. So you are getting here minus 5.746 into 10 power of minus 19 is coming. So do we have that option? We have that option A is the right answer. Hence nearest answer is coming, that is option A is the right answer. Find the formal charge of oxygen 1, oxygen 2, oxygen 3 and nitrogen 4. So formal charge formula, this is a chemical bonding question. What you can use? Valence electrons of central atom minus number of lines minus number of dots. Dots means electrons. Lines means bonds. So this formula use it, we'll get the answer easily. First, oxygen 1 case. Here what happened? Valency of oxygen 6 only. Number of lines, how many? Only one line is there. Number of dots, how many are there? Here, coordinate bond, no? 6 dots are there. That means what will happen here? Minus 6. Minus 6 plus 6 cancel out minus 1. So here minus 1 is coming. For the case of second oxygen, what we have? Second oxygen, again valency 6. Number of lines, only 1 is there. Number of dots, how many are there? So 1, 2, 2, right? So we'll be having, so they're already given minus 1 charge, no? So no need of calculating there. So you can take here minus 6 here, again minus 1 is coming. So here again 6 electrons are there, minus 6, minus 6. So here also minus 1 is coming. Oxygen number 3, what we have? 6 valence electrons, 2 lines are there, and there will be a 4 dots are there. That means 2 lone pairs are there, like this. So 0 is coming. So here it is 0. Now nitrogen case what happened? Nitrogen 4. Here valence electrons 5. Number of lines is 4. And number of dots 0. That means plus 1 is coming. So it is coming plus 1. So respectively they're asking, no, minus 1 minus 1 0 plus 1. Minus 1 minus 1 0 plus 1, option 2 is the right answer. 16th question. Chlorobenzene they given, the incorrect statement is, this is product, means P they given. P is less reactive than benzyl chloride towards a nucleophilic substitution reaction. Perfectly right. Why? This will be having the partial double bond character is there. So it is not reactive. It is not reactive. But if you take the benzyl chloride, no, there is a good reactive. Benzyl chloride, it is a good reactive because benzylic carbocation will come after leaving of this chlorine. So statement is correct. In fast product, carbon to chlorine, Cl bond has double bond character, no? Yes, if you see here, no, its structure will be having the like this. If I make here, double bond character will be there, like this, partial double bond. Lone pair donation will be there, no? So this will be correct. Chlorine is orthopara directing towards a electrophilic aromatic substitution reaction. That is also correct because of lone pair is there. It is deactivating the benzene ring, but allow electrophile at the orthopara position. C is correct. So P can undergo nucleophilic substitution reaction at normal. No, that is not the right. So this will be not normal condition. We need to apply around 600 atmosphere. 6 and take here 623 Kelvin temperature and 300 atmosphere. Then can take a base condition. We can take this reaction. That is a Dow's process. So this reaction not possible at normal condition. So this fourth option is the incorrect statement for this one. That means that is the correct answer for this question. Which of the following statement will have correct element according to this one, right? If you see this one now, atomic number is 79. Atomic number is 79. So first find out the group and place of this one. If I take this one now, so let us take helium, neon, argon, krypton, xenon, radon. So its atomic number 2, 10, 18, 18, 36, and 54 and 86. So it's 79. That means what happened? This is the radon, right? 86, 85, 84, 83, 82, 81, 80, 79. So here 17 group, 17 group, this is 18 group, 17 group, 16 group, 15 group, 14 group, 13 group, and group 12. Group 12 is which one? It is of zinc group. This is the copper group. So in the copper group, what happen? You will be having the gold will be there. You will be having the gold will be in that case. In this case, you will be having the gold. Or above will be silver, below will be rotation will be having this one. So this atomic number will be 79 you will be having. Now first ionization enthalpy is maximum. Yes. The first ionization enthalpy of this one is maximum. Right? First ionization enthalpy is minimum. No, it is wrong. It belongs to 10th group. It's not 10th group. No. So right. So let us keep this one. 18 group, 17 group, 16 group, 15 group, 14 group, 13 group, 12 group, 11 group. So it is 11th group. So it is not the 10th group. And it's not having the minimum. Wrong. It's not belong to fifth period. No. Right. It does not belong to fifth period. It belong to sixth period of periodic table. So this is wrong. So option 1 will be the correct option for this. An element form first transition series, element from the first transition series, that means 3D series, and another element from third transition series, that means 5D series. Same group do not liberate H2 gas from dilute acids like HCl. So the one which do not liberate is copper cannot liberate, gold cannot liberate H2 from acids. Both form halides. So it will form halides like this. Cu, Cl4 minus will form, right? It will form. So Au, Cl4 minus 1 will form. Okay. So the hybridization of central metal ion will be how much? Hybridization of central metal ion will be how much it will be? It will be sp3. This will be dsp2. Why? It is tetrahedral. It will be square planar. So option will be having 3 is the right answer. Now, 21 question what we have, numerical type. Sodium extract of organic compound. Sodium extract of organic compound. 0.1 gram is treated with a chlorine water and CCl4 which dissolves in organic solvent to produce a violet color. See, violet color given, there is a iodine will be there. So upon treating AgNO3, yellow PPT will be forming. So if I take sodium extract, then organic compound, right? So assume that in that halogen is present. So what will form here? NaX will form. Now NaX when you treat with the AgNO3, it will be forming AgX is forming. So now if X is equal to iodine only, you will get the violet precipitate will form. Violet PPT. Now for that case, what happen? Percentage of iodine is equal to, so weight of AgI by weight of organic compound into atomic weight of iodine by molecular weight of AgI. Right, this one into 100 we can do in this condition. So this is a formula we can use this one. This method is Carius method. Carius method you can use. Iodine atomic weight is 127. Silver atomic weight is 108. Right, this one we have. Now upon solving this one, how much will get here? So 5, 3, 235 is coming. Now use the formula. Percentage of iodine is equal to weight of iodine the given AgI the given is how much the given. So 0.12 it is producing. By weight of organic compound is 0.1 and atomic weight of iodine is 127. Then by molecular weight is 235 into 100. So when if you do this calculation, how much we're getting here? It is 235 into 0.12 and 127 into 0.1. divided by, so you're getting 45% is coming. You're getting 45% will be the right answer for this question. So option is not there. The answer for this one, 45 percentage of iodine is coming. Now here what will happen? Mhm. So here are the question is equation they given that aluminium solid, HCl aqueous and AlCl3 forming, H2 gas is forming. Which of the following is correct they're asking. With excess of aluminium they told volume of H2 produced per mole of HCl reacted will be 33.6 liter at atmosphere. So HCl gas, right? So how to do this one? So here what happened with excess of aluminium, H2 gas is produced. H2 gas will be produced. So one second, we'll solve this one. With excess of aluminum. So aluminum, this is the limiting reagent now. It is a not limiting reagent. Okay. With excess of aluminum, volume of H2 gas produced will be for mole of HCl reacted will be 336 means 33.6 liter atmosphere. So here let us take here what will happen. Aluminium reaction H2 gas produced per mole. So let us find out this one per one. So 33 point. Okay. So let us take here 2 moles of aluminium is reacting and giving 3 moles of H2. Right. So then per 1 mole how much? So for aluminum per 1 mole will be 3 by 2, that is 1.5. So here moles of for 1.5 moles how many liters of volume is coming? Number of moles is equal to volume of H2 by 22.4. How much moles here? 1.5. So when you do here 33.6 liters of H2 is coming. So that is given, first option is correct only. Now with excess of aluminium, volume of H2 gas produced per mole of HCl reacted will be 11.2 liters. So in this case, what will happen? Let us take, so here 6 mole of HCl, it is giving 3 moles of H2. That means what happened here? You are getting for 1 mole of HCl how much? 3 by 6. That means 1 by 2. 1 by 2. This is a mole. You got it. That means moles is equal to volume of H2 by 22.4. That means mole is 1 by 2. So volume of H2 by 22 point. That is 11.2 is coming. So 2 is correct. See guys, with excess of HCl, moles of AlCl3. So here this also we don't know. With excess of HCl, moles of AlCl3 produced per mole will be reacted how much? Only 2 only, no? Here 2 only reacting. Now this is correct. So 1 to 3 correct. So fourth will be wrong only. Why wrong? HCl will not produce the volume. Here it is a aqueous condition we have taken. So 4 is the wrong statement. Right? So which of the following is correct statement? The question was framing. So 1 second. So here it will not come 33.6, no. If I take here, no. So this has to be not in this way. So here volume of H2 is coming 11.2 liters, not 33.6. So this is wrong. So this is right. Now excess of HCl moles, excess of HCl no. So it will be if with excess of HCl, moles of AlC3 produced per mole of Al2 will be reacted to. So that is not 2. If I take 6 moles of HCl, no, how many moles here? 2 moles of aluminum. That means 3 moles has to come. They given 2 moles. That is wrong answer. So HCl produce 6 liter of H2. So it is wrong only, no, right? 12 liter of HCl we should taken as a, we have taken aqueous condition. So option 4 is right. Sir, option 4 is wrong. Option 3 is wrong. Option 1 is wrong. Option 2 alone right. 11.2. Now next question we have matching condition. Isothermal reversible condition work done. So what we have? Isothermal reversible W is equal to minus nRT ln V2 by V1. So N how much they given? 1 mole they given minus R how much they given? R is if not given take 8.314, right? So 8.314 joule. Temperature they given as 300 Kelvin into ln V2 how much? 20. V1 how much? 2. Decimeter cube means liter cube. So 2 to cancel out. So what you get here is finally you got ln 10. So ln 10 you got it ln 10 into 300 into 8.314 you got it. So if it is coming minus 543.1. It is in joules. So the answer is should be kilojoules 5.74. So where we have, so this will be D is coming. Now same thing if I do the isothermal irreversible. Irreversible case what will happen? In this case irreversible case W is equal to minus P into del V. External pressure into del V. Pressure is how much they given? 3 kilopascal. Convert into atmosphere. So 1 atmosphere is equal to 10 power of 6 pascals. So 10 power of 6 pascal. That means what happened? So here we need to take first they given 3 kilopascal. 1 kilopascal is equal to 1 pascal is equal to how many atmosphere? 10 power of minus 6. That means 10 power of minus 6 atmosphere into 10 power of 3 and atmosphere. You got it. V2 minus V1. So V2 how much? 3. V1 how much? 1. It is in meter cube. 1 meter is equal to 10 power of minus 2. So 10 power of minus 2 or plus 2 or 10 power of plus 2 centimeter. 10 power of plus 2 centimeter. Then 1 meter cube is equal to 10 power of 6 centimeter cube. So here 10 power of 6. So here what we have plus 10 power of 6 minus 10 power of 6 cancel out. 3 into 10 power of 3 into 2 you got it. But here this is atmosphere, this is in ml you got it. Convert into liter, 10 power of minus 3 liter. So 3 cancel out minus 3 plus 3. So how much left out? 6 you got it. So here you got liter atmosphere you got it. That be equal to the joules only, no, right? 1 liter atmosphere is equal to 1 liter atmosphere is equal to 101.32 joules. So multiply here 6006 kilojoule joules you got it. Joules you got it. But the answer is in what we have. It is in joules only, no. Kilojoules only, no. Let us take here 6 will come in this case. 2 case 6 will come. That means 2 case B is the correct answer. Okay, now third one what we have, 1 mole of a gas undergoes constant pressure del H. Del H is equal to NCP dt. Direct formula substitution, guys. Direct formula substitution. So temperature, change in temperature, they given 400 Kelvin. And now number of moles is 1. CP 5R by 2. R value can substitute here. R value they can substitute here 8.314. I'll keep here, I will remove this one. 8.3 into and temperature is 400. So after solving, how much you'll get here? So 5 into 8.3 into 400 divided by 2. So we're getting 8,300 kilojoules. 8,300 joules convert into 8.3 kilojoules. That means what happened here? A is coming. Now, in this case, del U is equal to NCV dt. Same answer. Same formula in different way. NCV dt. Number of moles is 1. CV value 3 by 2. 3 by 2, 8.314 into, so 320 Kelvin. So after solving, you will get the 5740 will come. Then if you convert here, 5.74, no, right? So after solving this, you will be getting, let us see how much will come. 8.314 into 320 into 8.314 into 3 by 2. So you're getting 3990. You got 3990. It is in joules. Convert into kilojoules. Approximately 4000 will come. That means 4. So this will be C is coming. So DBAC. DBAC. That is option B is the right answer. Now this question already need PYQ question. This one. So again repeated the same question model. Values alone changed. So find the temperature in Kelvin which rate constant are equal. So this K value both are equal. Condition they given K1 is equal to K2. Now substitute here 10 power of 4 e power of minus 2 4 triple 0 by temperature is equal to 10 power of 6 e power of minus 3000, that is 30,000 by temperature. So here plus 4 cancel out. Now bring this one here minus 2 4 triple 0. So right by t 3,000 by t is equal to 10 power of 2. Now if I take numerator, no, e power of minus 24,000 plus 30,000, right, plus 30,000 by temperature is equal to 10 power of 2. What happened now? 6,000 is coming now. E power of plus 6,000 will be by 2 is equal to 10 power of 2. If I take anti-log, no, means if I remove exponential, 6,000 by temperature is equal to ln 10 power of 2 will come. Now 2 will come backside, 2 ln 10 will come. Convert into log 2.303 and 2 log 10 value is 1. So we're getting 2.303 into 2 will come. Now 6,000 by 2.303 into 2 is equal to temperature you have. So that means what happened? If I do this one, 3,000 by 2.303 is equal to temperature, you will be getting 3,000 by 2.303. So the temperature you are getting in 24,000 minus 3, 6,000. Okay, by 2, 3,000 by 2.303. So here the temperature which you are getting here is temperature is equal to 1302.6 Kelvin is coming. That is the temperature of this reaction. Now what we have, E cell of the following reaction is this much they given. The given the E cell of the reaction is this one. Find the X value. So for that we should find out the here formula we have to use here. E cell is equal to E naught cell minus 0.06 by n log what we have q they given, no, q can take. E cell they given how much they given x into 10 power of minus 1. What about E naught cell value? E naught cell value cathode minus anode. E naught cell is equal to cathode E naught cell minus anode E naught cell. Anode. Cathode how much? Low, highest value. Highest value which one? Minus 0.44. Minus of minus zero point 0.9. So we'll get plus 0.46 is coming. Okay. Now substitute here minus 0.06 by n. N value how much? If you see here, no. So here stanness is plus 3. Here stanness how much? Plus 4. Right? Plus 4. Here bismuth how much? Plus 3. Here how much? 0. So how much is going? So 3 to 4 is going, no? 3 to 4. One electron is transferring. Here how many electrons? So here 3 to 0. 3 electrons are transferring. Here 3 electrons. Here 1 electron. Now balance electrons, no? So that means what happened? Here multiply 2. Here multiply 2. Okay. 1 second. So stand as minus 6 is equal to minus 2 plus 4 is coming. So um, minus 3. So H Sn O2 minus 1 Sn minus 4 is equal to minus 1. So Sn minus 3 is equal to minus 1. Sn is equal to plus 2. So here plus 2 is coming. So 2 to here 2 to 4. 2 to 4 means how many electrons are going here? Here going only 2 electrons. Here going 3 electron transferring. 0 to 3 means 3 electrons are transferring. That means what to do now? Balance electrons, no. Here multiply by 2. Here multiply by 3. So that means what happened? Total electrons are transferring 6 electrons here and 6 electrons here. That means n is equal to how much? N is equal to 6 will be the answer. So 6 is the electrons. Now log 10 power of 6 they given. Now bring this one here. You will be getting like this. So 0.46. So 6 cancel out. Minus 0.01 into 6. This will 6 will come to backside. Log 10 value becomes 1. So here 0.46 minus 0.06. After solving what we are getting 0.46 minus 0.06, you are getting, so 0.4 is coming answer. So 0.4 is coming. Which one? That is E cell value. They are asking E cell value into 10 power of minus 1. That means 4 into 10 power of minus 1 is the answer. The correct answer for this case is, so E cell value is equal to 4 into 10 power of minus 1. So x is equal to value how much? 4 is the answer. Now, which of the following law correct for this case? Henry's law again. So pressure is proportional to the x. Remove the pressure. So kh into x. Here they given the CO2. Here CO2 they given. Why? Apply the log for this case. No. Log PCO2. Log PCO2. Log PCO2 is equal to log kh plus log xCO2 we have. Okay. Now y is equal to c plus mx. So we'll be having the positive slope with intercept of this one. So this will be log p and this will be log x. So option will be 4 is the right answer. Now we have, for an ideal gas, volume is made 8 times, temperature decreased to 4 times. So here T1 TV raised to the power of gamma minus 1 is equal to constant. This one relation, PV raised to the power of gamma is equal to constant. So these two relations in the case of adiabatic process will be required. Here required is this one relation required for us. TV raised to the power of gamma minus 1 will be required for us. Now let us see here what will happen in this case. So T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1. So bring the T1 down, the T2 down, V2 by V1 gamma minus 1 we have T1 by T2. So temperature is decreasing. That means T1 is equal to T and T2 is equal to T by 4. That means what happened? T by 4. 4 will be go up, T cancel out. Now here V1 is equal to V2 is equal to 8. That means what happened? So 8 whole power of gamma minus 1. So we can write 2 power of 2, 2 power of 3, gamma minus 1. So bases are same, power should be equated. So 2 is equal to 3 gamma minus 3. So bring the 3 here. 5 is equal to 3 gamma. Gamma is equal to, so 5 by 3. 5 by 3 value 1.6 is coming. So 1.6 is coming, that is a monoatomic gas. If it is coming 1.4, diatomic. If it is coming 1.3, polyatomic. So that is monoatomic means helium will be the monoatomic gas condition. Okay, so thank you guys. We'll see the 23rd question paper morning again. We'll see tomorrow. Thank you.